All right, section 1.4 and 1.5 are going to be together here. So it's going to be adding, subtracting, multiplying, and dividing real numbers. So we'll start with adding and subtracting, and then we'll do the multiplying and dividing afterwards. So with this adding and subtracting, just recall that the answer to an addition problem, when we're adding something, the answer is going to be called the sum. And the answer to a subtraction problem is called the difference. So just a little bit of vocab there. So when we are adding or subtracting real numbers, it's definitely helpful to think of the number line in your head, or maybe draw it out if you have to. You're going to start with the first number in the expression and then move it either to the left or to the right. You're going to move it to the right if you're adding and to the left if you are subtracting. And just keep in mind that if we have something like, if you're subtracting x minus y, just keep in mind that's the same thing as x plus a negative y. So we'll start off easy. So we'll start off with just 2 plus 3. So obviously this is pretty simple, but I'm just going to draw the number line for it just so we get an idea here of what we'll be doing. So let's say this is 0, so I'm just kind of shifting it over. 1, 2, 3. So here is 2. So what we're doing, we're starting at 2 because it's the leftmost number in the expression. We're going to move it to the right 3 because of the plus 3. So 1, 2, 3. That gets us to 5. So our answer here is just 5. So obviously we probably already knew that, but that's just how you should, in my opinion, be thinking about these, using the number line like that. Okay, so maybe one that's a little bit less obvious. We have -2 plus -4. So if we have the number line, if we have -2 is right here. So we're starting at -2. -2 plus a -4 is the same thing as -2 minus 4. It depends on how you like to think of it. So what that means is we're moving to the left 4 units. So it's going to be 1, 2, 3, 4. So that's going to be actually be at -6. So that's going to be -6. Okay, so for 9 plus -2, you can think of this as 9 minus 2, whichever is easier for you. They mean the same thing. 9 minus 2 is 7. For 7 minus 9, so for this one I'll draw the number line out again. So we're starting at 7. We're starting at the leftmost one. 7 minus 9, same thing as 7 plus -9. I'm just going to keep on writing like this just so we know they're the same thing. So that means we're moving to the left 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That puts us at -2. So that's -2. And for the next one here, we have -15 plus 10. So what we could do here, we have two options. We could do it this way and say that this is going to be, draw a number line real quick. And we're going to start at -15. Since we're adding 10, that means we're going to the right 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you had this labeled, I just didn't label it because it wouldn't really fit. That would give us a value of -5. The other way to think of this is -15 plus 10 also equals 10 minus 15, or 10 plus a -15, whichever way you wanted to think of that. So whichever way is easier for you. If you have to rewrite it like that, fine. If not, then that's okay too. Okay, I'll do 3 more here. So -1 plus 6. So I won't draw the number line out this time. I'm going to say this is going to be 6 plus -1, or just 6 minus 1. So this is going to be 5. If you wanted to do it the other way with the number line, like I did before, start at -1, move it 6 to the right. Okay, next one we have a fraction. So what I recommend when we are starting with a negative and then we're subtracting another number, what I'm going to do, I'm just going to rewrite this as -1/4 plus a negative 2/3. So we're starting with the negative. We're making it more negative. What this is going to be, it's going to be the same as if they both were positive, and we added them together as if they were both positive, but our final answer is going to be negative. So that's one option how we can do that. The other one is keeping them negative. So I'll keep them negative for now, just so you can try the other one out on your own if you want. So what we have to do is get common denominators, right? So adding fractions, common denominators. So we have a denominator of 4, denominator of 3. The common denominator would be 12. So we would have to multiply the first one by 3/3. So we would get negative 3/12. So I'm just going to skip writing it because we should already know how to do that. The next one we have to multiply by 4/4. And we would get negative 8/12. So when we're adding or subtracting fractions, we add or subtract the numerators and leave the denominator the same. So I'm going to bring those negatives up here. It's going to be negative 3 plus a negative 8/12. Negative 3 plus a negative 8, that's negative 3 minus 8, will give us negative 11/12. Okay, so for this last one here, we have decimals this time. So this time I will do it the way that I mentioned for the previous one. We have a negative 2.6. We're adding another negative, which means we're subtracting 4.7. So what I'm going to say is that this is actually going to end up being the same thing as 2.6 plus 4.7, except our answer is going to be negative, because we're starting with a negative, making it more negative. So it's essentially the same idea as starting with the positive and making it more positive, except our final answer will be negative. So adding decimals, starting at the rightmost column, 6 plus the 7, we get 13, carry the 1, bring down the decimal, 1 plus 2 plus 4, and we get 7. So we get 7.3. So our answer is going to be negative 7.3. So once again, think in terms of the number line in your head, and hopefully that concept makes sense. So that was adding and subtracting. We kind of have been working with that for a while anyway, but just formally we'll went over it. So next for multiplying, once again, pretty much went over this, but we'll formally mention it. So recall that the answer to a multiplication problem is called the product. And multiplication is actually just repeated addition. So I'll do that in the example in a second. So here are some important properties. So the x and y just represent any number here. So anything times 0 will always be 0. Anything times 1 will always just be itself. X times negative y is the same as negative x times y. And negative times a negative is a positive, so negative x times negative y is positive x times y. So let's do some examples with a repeated addition. So 4 times 3. So we probably know off the top of our head that that is 12. But using repeated addition, what that means is we're going to add one of these numbers together, the other number's amount of times. So it does matter which one we choose. You get the same exact answer, but technically it's different. So 4 times 3, what this actually means is you add the second one together, the first number's amount of times. So 4 times 3 is 3 plus 3 plus 3 plus 3. It's 3 added together 4 times. So this is 12. So notice that if you did 3 times 4, this would be 4 times 4 times, or sorry, not times, plus 4 plus 4 plus 4, 3 times, which also gets 12. So the reason why this works is because multiplication is commutative. The order does not matter for the two factors being multiplied. But technically, Just because 4 times 3 is equivalent to 3 times 4 does not mean they represent the same exact thing. Next one, 5 times negative 2. So we're going to add negative 2 together 5 times. So it's going to be negative 2 plus negative 2 plus negative 2 plus negative 2 plus negative 2. So we add these together, we actually get negative 10, which you probably knew just by looking at the problem. Okay, so multiplication is repeated addition. When we were doing exponents, that would be repeated multiplication. So similar concepts there. So for division, for the last thing here, the answer to a division problem is called the quotient. And like we went over when we were dealing with fractions, dividing by a number is the same as multiplying by the reciprocal. So hopefully we remember that word. So all of these things right here mean the same thing. Using that division symbol, we have x divided by y equals fraction form x over y, which is the same thing as multiplying by the reciprocal x times 1 over y. So those all mean the same exact thing. So for example, if we had something like 30 divided by 6, that's the same as writing it as a fraction, 30 over 6, which is the same as 30 times 1 over 6. So all of those equal 5. So some properties for division. If we have 0 in the numerator divided by anything other than 0, 0 divided by x, that's going to equal 0. So 0 in the numerator equals 0, the whole thing. If we have 0 in the denominator, it's actually undefined. So x divided by 0 is undefined. It does not have an answer, it's undefined. And for the negatives, a negative x over y is the same as putting the negative in the numerator or the denominator. They all mean the same thing. Usually you're going to want to put it out front though, or in the numerator. You don't really put it in the denominator that often. And if we divide negative divided by a negative, that equals a positive. So let's do a couple examples. So the first one, 0 divided by 4. So 0 divided by anything other than 0 is 0. So there's a name for 0 divided by 0. That's technically neither of those options that we just mentioned. It's actually something called indeterminate form. We won't really be getting into it, but just kind of put that in the back of your head for now. So next one, we have 0 divided by negative 2. Once again, 0 in the numerator. This is going to just give us 0. Next one, negative 3 divided by 0. 0 is in the denominator, so this is undefined. So you don't want to leave your answer like negative 3 over 0. You have to write undefined. Okay, last one, negative 20 times 1/4. We know this is the same as negative 20 divided by 4. Negative divided by a positive is negative. 20 divided by 4 is 5, so negative 5. Okay, so we already did kind of a bunch with this stuff in previous sections, but now we just have it more formally defined. And that's actually it for these two sections.